Alrighty, as you guys can see, today we're going to work with solving problems with the distance formula and a midpoint formula. So you guys should have just finished up your test on rational expressions. Today we're going to work with radicals, which means square roots. Alright, I know, everyone's favorite thing. Okay. Alright, the first things first is distance formula. If you're watching this video and not taking notes, I suggest that you start taking notes right now. The best thing that you can do to memorize any formula and to get it stuck in your brain is to write it down. Not just write it down once, write it down over and over and over again. Alright? This is one of those that even I have trouble remembering at times. So the more you write it down, the better you'll do. So, if you take a look, the distance formula is your x minus your x squared plus your y minus your y squared. And you just have to make sure to match them up. So if you're writing the second ones first, make sure you write the second ones first. Okay? So say we name this the first and the second. So this is going to be 1 and 2. So when I plug this into the distance formula, you will get the square root of x2, so x2, which is at 4, minus the x of my first squared, plus the quantity of your y2 squared, or y2 minus y1 squared. I don't know why I put a 1 there. That needs to be 0. Alright. So, let's talk about what this means. If you think Pythagorean, a squared plus b squared equals c squared. A squared plus b squared equals c squared. Alright. Take a look at what we've got here. We've got a triangle, and it's a right triangle because you've got this vertical and the horizontal. So you've got a right angle, and the distance that we want to find is the distance between those 2 points. So that would be your hypotenuse, your c squared. Well, just your c. The c squared, in order to get rid of that squared on that side, you would square root both sides. So c is the square root of your a squared, which is your distance here, if we were to name this your a, and if we were to name that one your b, you could say the distance of your a, which is from your x to your x, which is that x2 minus x1 squared, a squared, plus my b squared, which is my distance vertically, so my y to my y. So that is your y2 minus y1 squared, because it's b squared. Okay, so that's kind of what we're looking at. And if you forget the distance formula, think about it on a plane like this. Even if you had a point way up here and a point down here, the distance straight across is still going to be that hypotenuse there. Okay, so if we go through and we solve this, I get that my distance is the square root of 4 minus 0 squared, which is 4 squared, which is 16, plus 6 minus 0 squared, which is 36. So we get 12 and 40, which is the square root of 52. Alright. So now that we have the square root of 52, Your next job is going to be to simplify that. Now, so then you would have to think, you might have to use a calculator, whatever you need to do. But we need to figure out if that can be simplified, if you can take anything out. So the first thing that I like to look for is whether it's divisible by a perfect root. And if you look, 52 divided by 4 is 13 if you were to plug that into a calculator. So if we take out a 4, and if we say that 52 is the same thing as 4 times 13, then I can say the square root of 4 is 2, and the square root of 13, well, I don't know what the square root of 13 is, so I'm just going to keep it as the square root of 13. There you go. Alright, let's try some other problems. Okay, we've got two different sets of points. So let's begin with our first one right here. I advise you, if you are walking through these problems with me, to again write down the distance formula. The distance equals the square root x2 minus x1 squared plus y2 minus y1 squared. Okay, the more you write that down, the more you'll remember it. I highly advise you write that down at the beginning of every single distance problem you do. Alright, so if I use these numbers and plug them in, the distance will be the square root of my second x minus my first x squared plus my second y minus my first y squared. Alright, and going through and simplifying, I'll get the distance as the square root of 2 minus a 4 is a negative 6 squared would be 36. 6 minus 5 is 1, squared is still 1. So I get the distance is the square root of 37. Now when I'm looking to see if that is divisible by a perfect root, I use my calculator. 37 divided by 4. Nope, not a perfect number. 37 divided by, well, 4 is 2 squared, so 3 is 9 squared. 3 squared is 9. 37 divided by 9, no. 37 divided by 16, no. And once I get to about that point, I just say, yeah, it's probably not. So there you go. Distance is the square root of 37, and that's as far as we can simplify it. Next problem. Take a look what we got here. Distance is the square root of x minus my x, negative 14, squared, plus my y, 8, minus my negative 4 squared. So if I simplify this, 1 minus a negative 14 is addition. Same thing with 8 minus a negative 4. 1 plus 14 gives me 15. Squared is 225. I've got my calculator sitting right next to me, so I advise that you guys do the same for walking through these problems. And I've got an 8 plus 4 squared is 144. Okay, so that was 12 squared. So if I add those two together, I get 369 underneath my radical. And if I test the square root of 369 I do not get a perfect number. Darn. But I should try and divide by some of my perfect roots. Now, if it helps you to write them down off to the side, definitely go for it. Okay, so if I write down my perfect roots, 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. So I'm going to test those guys. See if 369 is divisible by 4. Nope. 369 divided by 9. Yes. So, and I saw that 9 times 41 will give me 369. So I can pop that guy out. Distance is 3 square roots of 41. Now I want to double check 41 to make sure that that can't do anything else. And I'm not seeing anything that it does work with. So I'm going to say that that is my final answer. Alright, now we've got one more formula to talk about. Woohoo, the midpoint formula. This one I love. It's so easy to remember. If you really are thinking about it and you're not just kind of zoning out. So focus in if I've lost you. The midpoint formula is just an average. You're taking the average of your x's and the average of your y's. You've got two numbers, so you divide by 2. Alright, so if you think of this on a coordinate plane also, if I want to know the distance between, say, 0, 0 and 0, 4, I would cut the distance in half, right? It would just be there. If I want to know the distance between 0, 0 and 4, 0, I would just cut the distance in half. So doesn't it make sense that if I want the distance between 0, 0 and let's say 4, 4, that I would cut both distances in half, both my x and my y. So same idea here. So we're going to take both of our x's, negative 14 and 1, and we're going to cut them in half. And we're going to take both of our y's, negative 4 and 8, and cut them in half. And that would be the point that is in the middle. So, negative 14 plus 1 is 13. Whoa. That was a little messy. Okay, well that doesn't want to go away. So 13 halves is my x there. Negative 4 plus 8 is just 4. Divided by 2 is just 2. So your midpoint is 13 halves 2. And if you want to rewrite this as a mixed number, go for it, but I like just leaving it as a fraction. If you change it to a mixed number, then you go that extra step and you have a better chance of getting that step wrong. So, as many of you are hopefully watching this video ahead of time, you can begin the homework. I've posted the homework on both this section under BB9 and under the next section, because the homework has both midpoint and distance, but also simplifying, which we won't talk about until Tuesday. So, you can totally, 100% get started on the homework and probably finish a big chunk of it before we even get to simplifying tomorrow. That would be really helpful. Alright, so good luck. I've got printed copies if you need it. Otherwise, have fun. I'm hoping you guys did very well on your test. Looking forward to seeing your grades and seeing how things turned out for you. Alright, bye-bye.